Okay, to start off the second half, I will go through one question in the complex familiar series, and then I'll let you guys try the other ones. Yeah, I'll go through one of them. Okay, the question that I was talking about is question number 13. Okay. So question number 13 is about they give us the equation and then they tell us that the tangent passes through the origin. Okay. This is one of the harder ones. This is one of those kind of backward one where they don't ask you to find the tangent. They tell you something about the tangent and then they ask you to find something else. So in this case, you're actually finding the x-coordinate of the point that has that tangent. So to help you guys in terms of visualization of what it means, so first we'll sketch it. Right? We'll sketch this graph here. So y equals to 2e power x. That means there's no reflection and it's just a basic exponential graph. Right? 2e power x. Have you guys learned how to sketch exponential graphs?
Yeah.
Yeah, right? Okay. So remember e is just like 2.7 power something. So it's just the same thing. Okay, so that's the exponential graph. And then the tangent at a certain point passes through the origin. So whatever that point is, the tangent through that point passes through the origin. Oh, I'm just going to cheat a little bit. Let's say is this point here. All right. So let's say that the blue line is the tangent at a certain point, a comma e 2e power a. This is saying that the x-coordinate is a, and we need to find out what this x-coordinate is so that the tangent will pass through the origin. Okay. Now, looking at this a question like this, how do we even get started?
You could substitute, or you could find the derivative of y equals.
Good intuition. When you see tangent, you think derivative.
Then you can substitute in 0 as x to find that, and then you can find your and then using the original one you can find like a y coordinate to find the tangent equation.
We already know the coordinates of x and y in terms of a, but we don't know what a is though.
Yeah, so then you find the derivative of 2ex.
Yeah, so the derivative is 2ex.
0
into the x or the y value?
To the x.
To the x?
Yeah.
So you're saying sub 2e power 0,
yeah,
which is 1. What does that mean then? Oh, 2 times 1 is 2.
Like,
what does that give you? So remember, when you sub x into, so for example, when you sub x into the x value, which is 0, right?
is the y dash of 2ex 2ex?
Yeah, because 2 is the same, and then e power x is just e power
Why is
x.
2 the same? I thought 2, you lose 2.
You don't lose it because 2 is a constant. So when you
I
derive,
thought if it's a constant, it cancels out.
oh, it's a constant factor, sorry. It's a constant factor. So if it's e power x plus 2, when you derive it, this 2 is gone. So it'll just be e power x. But if it is 2 times e power x, then the 2 remains, and then you derive this, you get e power x. So it's still the same.
Okay. Yes, then you have 2 times 1, so then your gradient's 2.
Yes, so what you just found is the gradient at this point. Right? Because you said x equals to 0. That means it's that point. This is the point where x equals to 0. But not the point we're looking at. The point we're looking at is some point away from 0. Yeah, so now it's not the graph that goes through the point 0, 0, it's the tangent.
A for x?
Yes, you substitute a for x, so the gradient, right? So okay, let's say the gradient would be y dash of a, right? And that would be 2e power a. Okay, so what now? What now? How do we find a? Knowing that it passes through the origin. So what's the condition so that the gradient, so that the tangent will pass through the origin?
What do you mean, what's the condition?
Okay. To avoid some confusion, maybe I'll just give you guys, I'll guide you guys to the answer. the tangent passes through the origin. So when I think about this, right, if I were to sketch the tangent by itself, all right, if I were to sketch the tangent by itself, the tangent goes through 2 points, all right? So the first point is a 2e power a, right, which is the point on the graph, and then the second point is 0, 0, right? Yeah, makes sense? Now, it has to go through these 2 points, which means what's the gradient of the tangent?
Can't you use the
One sec.
the y2 minus y1?
Yes, that's actually the idea. So you have 2 points. Because you have 2 points, you need to use the y2 minus y1 formula. Right? I'm not saying this is wrong. I'm just saying that we put that aside and then we focus on this part here. So y2 minus y1 over x2 minus x1, because we have 2 points, right? Because we're trying to make use of all the information that they're giving us. So y2 is 2e power a, and then minus y1, which is 0, over x2 is a minus x1, which is 0. So we get another equation of gradient. That would be 2e power a over a. Okay. Okay. Now what? How do we find a? How do we form an equation to find a? How do we form an equation to find a? Any idea? So far, we can form an equation now, but how do we form that equation?
Can you make 2EA equal 2EA over A?
Yes, that's the right idea. So we have 2 ways of specifying the gradient, right? So the first one was using the derivative, right? This one is using the derivative, and then the second way was using the rise over run rule, right? If we can find the same entity, which is gradient, using 2 different rules, then we can equate them because they both should be equal to the gradient, right? So equate these, right? Equate these 2 equations, then you would get 2e power a equals to 2e power a over a. And then you can just divide both sides by 2e power a. So 1 equals 1 over a, therefore a equals 1. That's it. Okay? Yeah. So the trick here is to realize that you need to define the gradient using 2 methods. One method is rise over run. The other method is using the derivative. And then you equate the 2 because they must be equal to the same thing, which is the gradient. We don't know what the gradient is because it's 2e power a. We don't actually have that value. But we know that 2e power a you calculating in one method must be the same as the gradient calculated in another method. Right? And this is quite a standard. It's one of the standard methods of solving using multiple information. Right? You try to find one quantity using 2 different ways, and in this question is the gradient, which means you use rise over run and derivative. So use that, try question 14. All right, so try question 14 now.
Because there's because there's an x as well, it would be 1 over x equals ln a.
1 over a. So you are calculating the gradient. Not just the derivative, the actual gradient at the point A, at the point x equals A. So you need to substitute A into x.
Did we do that for the first one?
Yeah, we did. We substitute A in and we get y dash of A, which is 2 e power A. And that's how we can get rid of x. Right, because, so the, So the gradient is an actual value. It's not just a function, it's an actual value. And when you found A, which is E in question 14, that means the gradient is 1 over E. So it's 1 divided by 2.7. So that's 0 point something.
Why do you have E dash? What's E dash?
Oh, E power 1. That's power 1, not dash. Because ln A equals...
We have 1 equals ln A, then 1.
Yeah. So ln A is log base E of A.
Yeah.
Alright, so you convert it back to the exponential version. So E power 1 equals A. Any questions, Sarah?
How do you get rid of the A at the bottom? Of
Which one?
The denominators
This one?
of both of them.
Both of them. So the first one you derive ln x, right? Which means...
How do you get rid of the A?
Oh, how to get rid of the A? You times both sides by A. Right? If you times this one by A, if you times that one by A, then it will cancel out the bottom. Or another way of thinking about it is this. If you have 1 over A equals to ln A over A, then the top must be the same because the bottoms are the same. Alright, the bottoms are both over A, that means the top must be the same. Okay, so after 14, try 16.
Can you cancel out the ones?
Where?
A cubed plus A minus 1 and A minus 1.
No, because they're all terms. It's not multiplied. Only when you have multiply, then you can cancel out the factors, not terms. Yeah, 2 answers. Good. Very, very good. Right, here, I'll pass out the sheet for 8i. I'll pass it to Sarah. Hi. So, question 16 is just a bit tricky because of the
So are these chapters from our textbook for Unit 3 and 4?
correct. Yeah, so I think by the end of the holiday, you guys should be like almost an entire chapter ahead of school. Yeah, I say almost is because we won't do everything in chapter 8, up to 8i. I think if next week everyone can make it, then I'll move on to chapter 9 first. Otherwise, yeah, we'll do more. But ideally, if everyone should be able to make it for next week, and then I'll go on to chapter 9, which is antiderivative. That's the big part of Unit 3 exam. A really big part of Unit 3 exam is the antiderivative. Okay, all right. Let's move on. Okay, so we're moving on to 8i, rates of change. The only concept that's maybe new is the average rate of change. I don't think it's new to you guys, but
We've done it before.
right? Pretty sure you guys have.
It's just the gradient.
It's the gradient of the 2 points.
Yeah.
Yeah. Now the only thing that could be new is this weird formula here. Have you seen that before? FB minus FA. Okay, Sarah, you remember seeing that? Okay. Then it's just essentially the average rate of change between 2 points, right? And then the instantaneous rate of change is the derivative at a point.
Yeah.
Yeah. I guess that's if it's not new, then yeah, that should be fine. We'll move on to the questions then. Let's try a question. Skip the examples. Okay, question 4. Start working on it. I'll see how you guys go in terms of like whether you need help with this question. And I might explain the whole question, but otherwise, just get started with this one.
At what rate? What does it mean by at what rate?
Okay.
It's worded really weird. Like, what are we actually trying to find?
Okay. At what rate is the reservoir being emptied at time t? So they are saying the rate at a specific time. What do you think it links to? Hint: is it average rate or instantaneous rate? Average is between 2 points. Do we have 2 points here?
It'll be instantaneous, but how are you supposed to? Are you just deriving it then?
Correct. Yes. So this
Why is it worded so stupidly?
because the derivative is a mathematical concept, but like in application questions, you're applying it to a scenario, and what you care about is at what rate is it being emptied? Because now the application part is now you have to link the derivative to the meaning of it, which is
You
right.
don't derive 10 to the power of 3 though, right?
No, you don't. You leave it out, and then you derive
Does
what's.
it cancel out? Or is it that constant thing you're talking about?
It's a constant thing, yes. It's multiply, right? So it's constant multiplier. You just leave it as a multiplier. You don't need to do. You can't leave it out, but you just leave it. Okay. So at what rate? So this is saying that you link derivative gives you the rate of change. Okay, or the instantaneous rate of change. So this part, from now on, from the application questions, they won't ask you derive this equation. No, they'll ask you at what rate is it being emptied, or at what rate is it changing.
Change it, and do I leave it as like 10 to the power of 3, or do I make it?
You can change it. I would change it. So v dash t, I would change it into 1000, and then 90 minus t, everything power 3. So the 1000 constant will just be the same, and then you derive the brackets.
Yeah. So then
Yeah.
would it be negative 3000 times
90 minus t squared.
Correct.
Okay.
And that's it for question A, right? That's all they're asking you to find. At what rate at time t? Okay, so at what rate is it being emptied at time t? So if they don't give you a specific value for t, it's just meaning, oh, I want the general equation.
So when you do question B, you like divide 3,000 out, so it's just 0 equals 90 minus t squared.
Not squared. How long does it take? So yes, you're finding t to empty the reservoir. What does it mean by empty?
V equals 0.
V equals 0, yes.
Yeah, so then but you'd have to divide 0 by negative 3,000.
Not negative 3,000. You're looking at the derivative. You're not supposed to look at this one. So empty, the normal one, yes. Empty means Vt equals to 0. So you set 0 equals to V in the original equation because that's the volume equation. The derivative is the rate of change. Okay, so they're saying that the reservoir will be emptied in 90 days.
What's 90 cubed?
It's 81 times 9, which is 729. Just 719, was it? Oh, 729, yeah.
90 cubed.
Yeah, 90 cubed is the same as 9 squared times 9, which is 81 times 9.
No, 90.
Yes, I will deal with the 0 later. So the 90, okay, so sorry, I'll do it here. 90 cube is the same as 9 cube times 10 cube. Yeah, so that's why I'm working 9 cube first. So that will be 729. And then just add a bunch of zeros in. All right, so it'll be 3 zeros from here, 3 zeros from the initial 1000. So that'll be 729, 0, 0, 0, 0, 0, 0 cubic meter. So that's a lot of water. Water reservoir, yeah. That's a lot of water. That's 729 million cubic meter.
After what time is the reservoir?
So what is question D asking me then? Nothing else to do. What's question D?
Isn't that the rate?
Yes, the rate is equals to 2 times 10 power 5. Okay, so this one is saying that V dash is equal to 3 times 10 power 5. Find T.
How do you know it's 30 or 300,000? Because that
10 power 5 is 1 and 5 zeros. So you times 3 is...
why'd you add a negative to the front of the 3?
because it's being emptied. So, okay. Actually, okay, guys, have a look. Question D is a bit different. So, let's say if you don't put a negative at the front, because you're like, oh yeah, the rate is 3 times 10 power 5. Now, when you reach it up to this point, you divide both sides by 3,000, you would get, let's say, 100 over here. And you're like, hang on. Then that would mean...
by negative anyway.
Yes, so if you divide by negative 1, it will be negative 100. How can we square something and it becomes negative? We can't.
Yeah.
Right? And the reason why it doesn't work if you continue it this way is because you're missing the negative here. But why is there a negative in this thing here? Now, note the wording. the reservoir is being emptied, so the volume is decreasing. So the rate that they're giving you, in terms of actual rate value, it should be negative. Yeah, the rate is positive means you're increasing the volume, but the reservoir, the volume is decreasing, which means the rate is decreasing. Does it make sense, Sarah? Does it make sense why I add the negative in front of the 3 times 10 power 5?
Because it's being empty.
So the volume is decreasing. Yeah, the derivative gives you the rate of change, and if it's decreasing, then yes, the volume is decreasing. So when you put a negative there, then it makes sense. At the end, there will be no negative, and then you can solve it.
What's the negative? Does it go around everything, or do you have to put brackets?
Good question. Now, normally you need, if you have, let's say 3 plus something, you do need a bracket, right? But in this case, it's 3 times 10 power 5. So brackets or not, the negative is just -1 times into the thing, and it's because it's a whole bunch of things multiplied together. You can shift them around. So normally, if it's like something plus something, if it's multiple terms, you have to put brackets. If it's one term and a bunch of factors, you don't need to put brackets. So when we get up to this point here, one of these answers is rejected. But why?
Oh, is it because like the constant in the original equation is only 90?
So what about it? It's not about the constant. It's about something else.
It's when volume equals 0, the time is 90.
So which one is rejected?
100.
Correct. Because it's already empty at 90 days. So after 90 days, there's no more volume to decrease, right? So the model only works up to t equals to 90, okay? So this one means that t must be less than 90 days, all right? Because at 90 days, you already get 0 volume. Okay, at 80 days, that will give the rate at that value.
Do we have to sketch?
Let me see. Sketch. What's the equation?
I don't really feel like it.
No, it's fine. No need to sketch it. It's not that important.
So how do you know it's going to be like that shape, like a decay? How do you know it's going to be a decay? Because obviously like time's negative, but like how would you draw that? Because like I wouldn't know how to draw that.
Okay guys, for E and F, let me just walk you guys through it. You don't need to do it, okay? So I'll just walk you guys through E and F. So question E, sketch, what was it? VT. So VT is 1090 minus T everything cubed. And then F was V dash T.
I get how to do V dash T, because once you have like the first one, you can just like estimate it. But would you just find like the greatest volume and then like the greatest time, and they're just like drawn between it, like they haven't really been exact with it?
You mean for the V dash or V?
For V.
For V?
Yeah.
For V, normally you need to go through the normal pathway of finding the stationary point and then find the coordinates of a stationary point, and then you put them in
But
and then you
there
sketch
is
it.
no station.
You
Like
can't find it.
the start and end, yeah, but
Not start and end. Okay, guys, here. You don't need to go through it, just see if you can understand this, okay? If you want, you can go back and replicate this, but have a look. So based on what we've seen so far, it is empty at 90 days. So we know that the model for VT has to end somewhere 90, right? So 90 would be the x coordinate here.
Yeah.
And then they ask us to calculate the initial volume. So that one would actually give us the initial volume, which is like around here, right?
Yeah.
So this is your 7.29 million. Oh, no, 100 million. So times 10 to the power 68. All right, so it starts here. Now we don't know what shape it is yet. Okay, let's say we don't know what shape it is yet. So let's see how we can figure this one out. We have got the derivative, which means when we set that equals to 0, right? When we set the derivative equals to 0,
Yeah.
where's the turning point? Can you guess it? Okay, so first I'll find turning point, which is when the derivative is equal to 0. So set 0 equals to?
This T is 9.
Yeah, that's right. T equals to 90.
Well,
So there's only one turning point.
yeah.
Right, 90 minus t power 3, which is then must be 0. So therefore,
Is
the
it a
turning point. Yes, it's the turning point because the turning point is when the derivative equals to 0. Right, so it must turn around over here. And we can tell this is going to be a maximum because if it's minimum, it doesn't make sense. If it's minimum, there's no way you can get back to the initial without another turning point. Right, so it must be a maximum. Sorry, minimum here. Yeah.
But it wouldn't keep on going up though.
Yes, so it will be a local minimum and it will go up. But remember, we calculated the volume is 0 at 90 days, so it doesn't make sense to have this section of the graph.
So just stop it.
So it'll be like somewhere like that. Right, so now we roughly know that the shape looks like that. And at the moment, you guys don't actually know how to calculate like the points of inflection. That's unit 4 stuff. So what you can guess is that it will be like this.
Yeah.
Right, turning point, and there's no more turning point between here and here. Right, so there's no turning point. It must be like a nice graph. So then the bet is going to be like this.
Yeah.
Does it make sense? Because there's no other turning point.
And then you just do the opposite.
Yeah, somewhat. So for v dash t though, oh, this is power 2, sorry. It should be power 2, same thing. But yeah, so for v dash, if you want to sketch v dash, recognize that this is a quadratics. Alright, and if you apply the a minus b everything squared rule, then you get your 90 squared minus 2 times 90 times t, right, and then plus t squared. So you see coefficient of t squared is positive in here, but then you multiply that whole thing by negative 3000, which means this will be an upside down parabola, right? Because the coefficient of t squared is negative because of the negative 3000 times into t squared.
Well, can't you just do the whole thing where you just like sketch the derivative, like you don't actually work it out? Because like, that's what, when we draw the graph of the derivative, we don't work anything out, we just sketch it based on what we see.
Based on the original graph, yes, you can do that. You can, but it's a bit tricky in this case because this is a you can try to guess it is a quadratics, I think.
But it's not drawn as a quadratic here.
It is a quadratics.
Isn't it like an exponential growth one?
No, it's actually it's a quadratics. Yeah, that's why it looks a bit strange, but it is a quadratics that has a turning point at 90.
So it's just cut in half, like we're not seeing the other half.
You're just not seeing the other half. And they don't even give you the turning point, because the turning point, when you derive this thing one more time, you'll be able to find the turning point of the derivative graph, if it makes sense.
Why do we derive it one more time?
So in order to find the turning point of the original graph, we got to use the derivative of that, right? So to sketch the turning point of this one, you got to find the derivative of this one.
Why?
Because that's the rate of change of the gradient.
But why do we need the rate of change of the gradient to find the turning point?
The turning point of a graph is where the rate of that graph equals to 0. The rate of change of that graph equals to 0. If we are sketching v dash, right? So the rate of change, so you know how a turning point of v is when v dash equals to 0, right? So the turning point of v dash is when the v dash dash equals to 0. So it's the second derivative. This is unit 4 stuff. I'm not going to go through this.
Okay.
Right, that's unit 4 stuff. Unit 4 you will learn or turning point of the derivative graph. But in this case, you don't. That's why the sketch. I'm not asking you guys to do it because the sketch is something that you just punch into the calculator and then sketch it out. And for this question though, you can technically sketch it because this is just the turning point form of the of a quadratics.
Yeah.
Right. So turning point form. So we use turning point form instead. So that would be negative 3000. I'll swap the t and 90. So t minus 90, everything power 2. Okay. So remember turning point form, a times x minus h, everything squared plus k. Yeah, remember that?
Yeah.
Yeah, you should, right? It's for a turning point form from quadratics. So a is telling you whether it's concave up or down. So we know this one is concave down because a is negative. And then the turning point is h comma k, which in this case is 90 and 0. Okay, so it is a quadratics. It has a turning point at 90 and 0. So v dash will be like that, and then let's say this point is 90. It will be a upside down curve, right? So turning point is at 90, and then it will look like that. You just don't draw the part on the right hand side because it doesn't make sense, right? The model is stopped after 90 days because the reservoir is already 0 volume at 90 days. So you only sketch the left part, and also it doesn't make sense for t less than 0 because before that it hasn't started emptying yet. Okay, so you actually stop at when t equals to 0. And then you gotta find what happens when t equals to 0. So when you sub 0 to t, you get 90 squared times 3000. So if you really want to work it out, this one would just be v dash at 0, so the initial rate of empty. So that would be negative 3000 times by 0 minus 90, everything squared, which is 90 squared. So that would be 81, and then 2 zeros times by negative 3000. All right, so do 3 times 81 is 240 plus 3 is 243. And then you add back the 0, 5 zeros. And negative. Yeah, so this number there is negative 243 and 5 zeros.
Would you put it in the scientific notation?
Yes, you preferably put into scientific notation. So negative 2.43 times 10 to the power 36. Is that the answer? Okay.
5. It's 5?
Is it 5?
There's 5 zeros there.
Oh, actually, sorry. Actually, should be 7. My bad.
Yes.
7. Yeah, because to make the dot goes here, you gotta go 1, 2,
Yeah.
then 7.
How do you do question 5?
Question 5 is.
That one looks harder than 4.
No, it's actually.
Or isn't like to derive it? Like I don't want to derive that.
Okay, I'll walk through question 5. There's an important concept in the important technique in question 5. It's not something that you will learn at school, so it's good for me to mention this here. The teacher won't go through this. If you get it, you get it. If you don't, well, you just won't be the 99.95 ATAR student. Anyway, when you see an equation like this, right, it looks scary. Like, oh my god, that's like a fraction, and then you times, and then power 4, power 5. It's actually not that scary because what is being multiplied in is a constant. All right, so you're using that rule, this important rule where, so question A is just deriving, right? So v dash t is essentially, okay, I'll write something that may look a bit strange, okay, but it will help you guys visualize what is happening here. So I'm saying, okay, this is deriving, I am deriving this expression here, 1 over 160, 5t power 4 minus t power 5 over 5. Right? So when I'm trying to derive this entire thing, and part of that is actually it's actually has a constant factor multiplied in, you can take the constant factor out first, and then you only derive, so times by, you only derive what's inside it.
Yeah, but how do you derive t5 over 5?
T5 over 5, again, is dividing by a constant number. Alright, if you're dividing by a constant number, you can just bring that and you can just ignore the constant factor first. Right, so it'll be 160 and then times by, now I actually derive it. The 5 in 5t power 4 is the same, and then I derive t power 4. Oh, well, you guys did this one before, so 4 times it down will be 20t power 3.
Yeah.
And then minus, so note that you have to put into brackets here. And then t power 5, just bring the power down, which is 5 t power 5, power 4 over 5. And yeah, that's it.
So you just ignore the 5 at the bottom?
Yes, because it's just 5. If it has a t, then it's going to turn into a quotient rule. But if there's no t, it's just a number. Or if they say that if it's a letter, but the letter is a constant, then you can just ignore it and derive everything else and multiply that back in. See this
Do
one?
you switch them their order? Like, no, actually, don't.
Yeah, normally you would leave the highest power first, but in this case it's a subtraction, so they actually prefer to write it in this way, so as a subtraction. But yeah, so then 5 divided by 5 is just gone, so that'll be 20t cubed minus t power 4. Okay, so the important technique that I want you guys to remember is ignoring, well, not ignoring, but like you can take out the constant factor and then you only derive what's inside the brackets.
Why can't you take out the 116?
The 1 over 160?
Yeah.
Because it's only a constant factor. So this is a special rule of the derivative, where so when you derive, right, a constant factor a times by a function of x, right? This is the same as you can take out a constant factor and then you multiply it, and then you only need to derive just the function of x separately. So this is the important rule here, that when you apply to it, you can ignore some scary looking constants. Sometimes it might be k, like a letter, like what? But no, it's just a constant number, that constant factor. You can just take that out and then derive everything else.
So for question 6, would you just like look at the graph and go like, at 100, like 250ish and like blah blah blah?
Yes,
Do you
yeah.
have an equation?
Yes. So you're not given an equation, so yeah, you're only estimating.
Okay.
Yeah, so we'll try to go through as many of these ones as we can, but
7.
let's see, when is the rate of flow? Okay, guys. Question 5c, when is the rate of flow greatest? How do we find this?
Wasn't it the turning point?
Of which graph? V or V dash?
V dash.
Yes, it is a turning point of V dash, or the highest point of V dash. Okay?
Yeah. So now how do you find that? Did you actually work that out?
No, this I think question 5 is most likely a calculator question.
Oh, okay.
So you sketch it using a calculator. So for question B, I'll just
And
give
then
you guys
just do like
the maximum thing. Yeah. So for that question, we will look something like that. So once you sketch it, then if they ask you for when is the rate of flow greatest, that's essentially just a top point, right? Because this is V dash, that's the rate. So when is it greatest is when it is the highest in the graph.
Yeah.
So yeah, that is correct. Okay. All right. Yeah, I think actually from now to the end of the lesson, I'll just go through the concepts of some of these questions, but like you guys will try it later at home.
Okay. Find the value of P.
Okay, wait. Charlie, wait. Let's work through these ones together.
I want to do that.
You want to do this one?
Can we do 7?
Yes, we can do 7. Okay, 7 has some new stuff. That's fine. But yeah, I'll just talk through the ideas. I will not give you the answer. Rate is 0. What does it mean?
When the gradient is 0.
Yes, when the gradient is 0, right? And then the estimate of the rate of flow at t equals to 200. How would you estimate this?
You'd like get a little rule and go.
Yes, correct. You would find the point and then you draw that, and then you have to choose 2 points and estimate the rate. Okay, because the rate is the gradient at that point, 200 here. Oh, I missed that, but yeah, like that.
Yes.
Okay.
Do like slightly before and slightly after, right?
No, actually, ideally, you do a lot before and a lot after.
Okay.
Yeah, so because as long as you draw a straight line with a ruler, right? If you choose this point and that point, it will, maybe, I don't think you can do the point on top. You can't see what the y value is, but see roughly where this one is.
Yeah.
Okay, the further the 2 points are, it will be more accurate. Because if you choose 2 points that are too similar, it's like you're saying 8 and 7, then, well, what's the difference here? It's a bit harder to guess.
Yeah.
Yeah, so choose 2 points that are further away. So one top here and one at the bottom here. So 1 and, I don't know, 150 or something, depending on how you draw the line. And then find the average rate of flow. So how do we find average rate of flow?
y2 minus y1.
y2 minus y1 over x2 minus x1. So find the y and x at 100 and 250 and do that. State the times for which there is net flow into the reservoir. What does it mean by net flow into the reservoir?
Like total?
Yeah. Yeah, what does it mean by total? Expand more. I'm looking for a keyword. I'm not hearing it yet.
Like the greatest flow?
Not the greatest flow?
I don't know.
Okay. What happens when the okay, let me ask you guys one question. What happens in this section here? What do you guys think is happening in this section here? Remember, this is the V graph here, the volume graph, not the rate.
Volume
Yeah. So what happens in this section here?
decrease.
It's decreasing. So is there net flow into the reservoir?
No.
No. Right? Net flow into the reservoir would cause the volume to
Increase.
increase. So net flow into the reservoir means V dash is more than 0, or the gradient is positive, right? Or the rate is positive. Same thing. V dash, gradient, rate mean the same thing. Okay. So net flow into the reservoir means the rate of flow is positive into the reservoir. Right? If it's net flow out of reservoir, means you're looking at the other section. So for question D, it will be that section there and this little bit section there. Okay, so at those sections will be the net flow into the reservoir because the volume is increasing.
Do you find like the points, like a stationary point, and then find like the
Correct. That is correct. From stationary point to stationary point would be the best option from this to this here, and then from the stationary point continuing would be the other section. Yeah, because the stationary point is when it changes from decrease to increase. Right. So start from the stationary point. Good. Yeah. So next is question 7. A car tire is inflated. Oh, by the way, we're not going through any question in this chapter next week. Yeah, you guys just need to do these questions at home. Because these ones are like, I think you guys can do these ones. It's just each of you will have a different question for me. So work it out by yourself. If you have a question, ask me on Discord. Please ask me on Discord. I need to see you're actually working on these questions, okay? I'm not going to assume that you guys can do every single question by yourself. I don't know, maybe Charlie you can, I don't know. But everyone else, please, unless you are getting 100 out of 100 for your exam, I will not for 1 second believe that you can do all these questions without any issue. So no questions, you guys not doing anything, is my assumption. Or not doing enough. Okay, a car tire is inflated to a pressure of 30. 8 hours later, it is found to have deflated to a pressure of 10. So inflated to a pressure of 30, that means that at T equals to 0, the pressure is 30. Make sense? Mm-hmm. Yeah? 8 hours later, so at T equals to 8, it is found to have deflated to a pressure of 10. Then P equals to 10. Mm-hmm. Okay? And then the pressure of P at time T is given by that one, so we'll use T equals to 0, P equals to 30 first. Alright, let's see what we've got. 30 equals to P0, and then...
Is P0 your initial?
It is your initial, yes, correct. I'm just showing you guys the actual math behind that. But yeah, E power 0 is just 1. That's why 30 is just equals to the initial pressure. Alright, and then the next part would be lambda. So we know that...
the extra one?
Yeah, use T equals 8 and then the pressure equals to 10. So 10 equals to initial pressure, which is 30, times e to the power negative 8 lambda.
Wait, slow down. Going really fast.
Yeah, because I'm just showing you guys the main ideas only, okay? I'm not going to work through every single one of these questions.
What's the thing? I thought it was...
This thing?
What does it represent in this question?
Lambda, it's a constant. Yeah, so okay, so in this question you can see that P is like the main variable and T is the independent variable that the time changes, and then any other variable you can safely assume to be constant. So in this case lambda is a constant factor. Okay, so that's why they ask you to find the values of P0 and lambda. Right, so P naught is just 30, that's the initial pressure, and lambda, well, you need to use the other point in order to find lambda.
Wait, so then you do 1 over 3 equals e to the power of negative 8 lam, and then you have negative 8 thingy equals log.
Lambda.
I don't like it.
It's,
Equals
it's,
log
it's,
base
a,
e
it's
of
just
1
a
over
Greek
3.
letter. Negative 8 lambda. So ln, you have to, actually, no. This
We
one
do
will be
log-
easier if you convert it to 1 over e to the power 8 lambda. Then you can equate, because the top is both 1, you can equate the bottom.
Wait, why are you doing why is it 1 over that?
Because it's
I thought
negative
that's what
power.
happens when you do that. Actually, don't.
No, it's negative power, right? Yeah? Make sense?
Mm-hmm.
Yeah, Sarah?
Can't you change it into log form?
You can. So I'll show you two versions. This first version, I think, is an easier one where you convert it into the fraction first so that you can just equate the bottom. And then ln 3 equals to 8 lambda. So then lambda would just be
Yeah, because
1
either
over.
way, don't you have to do it in log? So
Yeah, either way, yes. So I'll show you the other version. So let's just say this one we go to log straight away. Then you would get ln of 1 over 3 equals to negative 8 lambda, right?
yeah.
Yeah, so then you divide by 8, so it will be negative 1 over 8 ln 1 over 3, you got to convert that to 3 power negative 1. And then you bring your negative out to
Wait,
the
why
front.
is it 1 negative 1 over 8? Oh, you're dividing.
Yeah, dividing it by negative 8. Alright, so then I convert this one to power negative 1, so I can take that out and cancel out the negative at the front. So then it will be this. Same answer, but I prefer the first version because I don't need to deal with like ln of a fraction of 1 over something. Because you need to remember to convert 1 over 3 into 3 power minus 1, otherwise you won't be able to simplify it.
Yeah.
Yeah, so that's why I prefer the first version here. I think it's better. Either way, you get to the answer. So that's the lambda value and then the p naught. So then you would write p equals to, right, write the final answer. P equals to 30 e to the power 1 over 8 ln 3. Well, I think they put negative lambda, so negative of that times t. A little bit tricky.
Times t.
Yeah, because the function is p and t. Okay?
Yeah.
And then at what time would the pressure be 8? So I'll just go through the ideas.
Do I have to substitute in? I thought we were finding. Yeah, okay, don't worry.
Yeah, we're finding lambda. Yeah, so once you found lambda, I prefer to write the final equation, right, with the p0 and lambda in it.
Yeah.
Yeah. And then at what time would the pressure be 8? What do we do?
Substitute in 8 for p.
Yeah, substitute 8 for p and solve for t. Now, solving for t is not going to be that straightforward. Okay, it's not that straightforward. Let me check if the answer is a decimal number. If it's decimal, then you can use calculator. Yeah, it's a calculator question. Okay, good luck. They're lucky for you guys. Then you can use calculator to work this one out. So in fact, you can actually work this lambda out to be a decimal number. So 0.1373 equals to lambda, and then you can use that value instead.
In exams, you know how if you get like a decimal number, you need decimal points because if you have to substitute a number back in, once you get it wrong,
Correct.
it's like
Very good, Sarah. Very good question. I will actually go through that idea now. So Sarah's question is, if we have a decimal number here like lambda, and we have to use that in like the equation, like how many decimal points? Let's say given answer is in 4 decimal places. Okay, this is actually what I would do for this lambda value. So I'll show you guys. Let's say we know this is tech free and you get up to this point, so then you would write lambda. There are 2 versions. You write 2 versions of lambda. So lambda equals to, let me punch that in because they don't give me enough decimal place here. ln of what, 3? Okay, so I write 2 versions, 0.1373, 2 more. Okay, if the question asks you for 4 decimal places, you need 2 more than that. So 137327. And then I write 1 more version of lambda to 0.1373. So I will show this one as a value of lambda to show, because they ask, oh, find lambda to 4 decimal places. You show that value. However, when you use lambda into the equation, p equals, you use the longer one. So 30e to the power negative 0.137327 t.
Can you work this out for? I don't know my calculator.
Yeah. Is it for question B?
Yeah. Find T.
Yeah, just work through it later.
Perfectly.
Okay. Yeah, don't worry about it. That's why these questions are not hard. Okay, I'll just go through the ideas only. You guys don't need to do it now. Find the rate of loss of pressure. What are we doing here? Question C.
The rate we derive it.
Yeah, you derive and then.
Then you substitute in t equals 0 and t equals 8.
Yeah, so t equals 0 into
That.
p dash.
How do you derive p dash?
P dash. So I'll just show you question. So B is easy. Question C. So P dash would be again 30 constant number. It just be 30 times when you derive e to the power something t. This is just a constant.
The one that has your values like all in it.
Yeah.
Okay.
Yeah, and e to the power that just means it will be the same thing, right? E to the power anything will be the same, but you need to derive the power, and that will just be a constant times t. So you just times it by whatever that constant is.
Yeah.
Yeah? Does it make sense, Sarah? So this one, the form of that is like e to the power at, right? Yeah, so when you derive it, d over dx would be a times e to the power at, because you derive the power a times t, you get a. Right, and then you times it to the front. Oh god. In this case, I times it to the back here. Okay. Alright, that's it. I will not continue on this chapter next week. I think, yeah, you guys need to go back and do the question. Okay. I may go back to this chapter closer to the exam to go through some harder exercises as practice. But no, next week we'll move on. Cool. G, H, and I, 3 chapters in one day, not bad. Okay, not bad. Your derivative skill is quite strong. See if you can apply that to do anti-derivative next week.